line here, well, M2, it's minus the A value, which is minus 3, okay, divided by the B value, which is minus 2, which gives us 3 over 2, okay? And hopefully we can actually see that M1 times M2 is equal to minus 2 thirds times 3 halves, okay, which gives us minus times plus gives us a minus, okay. 2 times 3 gives us 6, and 3 times 2 gives us 6. So actually what we end up with is M1 times M2 is equal to minus 1. And so these two lines here must be perpendicular to each other, okay. So if you want to actually, given a line, if you want to find a line that's perpendicular to another line, okay, so let's say given a line, okay, how to find, okay, a line perpendicular, okay. Well, okay, so any line, so given a line, let's say we have, let's say if we have ax plus by is equal to c, okay. The slope of this line here, is it's minus a over b, okay. A line perpendicular, okay, 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 its slope times this slope here must equal minus 1, okay. So we have minus a over b times the slope of this other line, okay, it's m, must be equal to minus 1, and therefore we have the slope of this perpendicular line m must be equal to, well, it must be equal to minus, multiply across by minus, this actually gives us a minus 1 times a minus b over a, okay, which therefore we end up with m must be equal to b over a. The slope of this line must be equal to b over a, okay. So if the slope is equal to b over a, let's just put that into y-intercept form, okay. So the line that's perpendicular must be y is equal to b over a times x, okay, plus some constant, let's say d, okay. Multiplying across by a, we end up with ay must be equal to bx plus some other constant, it's ad, so let's say some constant e, okay, which bringing the e over, this gives us then bx minus ay must be equal to, well, it's the e becomes minus e, so actually let's call it some constant f. So you can actually see that the line that's perpendicular to this line here, okay, so the line perpendicular to ax plus by is equal to c is actually bx minus ay is equal to f, okay. This is the line that's perpendicular to this. So for example, okay, a line that's perpendicular to 3x plus 7y is equal to 2. A line that's perpendicular to that, okay, a perpendicular line to that would be, okay, well what we're going to do is we're going to flip them around. We're going to flip the a and the b around, okay. So we're going to say it's going to be 7x minus the coefficient minus the a minus 3y is going to be equal to some number k, okay, or some number f. That this line here is always going to be perpendicular to this line here. So actually we have an infinite number of them. We could have 7x minus 3y is equal to 2, 7x minus 3y is equal to 20.5, and so on and so forth. But effectively what we have is we have lines that are, we have that lines that are perpendicular to each other, and there's many of them here. Okay guys, just a quick recap here. What I was really saying here is that lines that are parallel to each other have the same slope, which means that when you divide one line slope by the other line slope, you should get 1, okay, which makes sense. They're the same, m1 must be the same as m2, so that should give you 1. And then lines that are perpendicular to each other, okay, when you multiply the two slopes, you should get minus 1. That's for lines that are perpendicular to each other. And these are two really important identities for us, okay. So parallel lines have the same slope. Perpendicular lines, okay, when you multiply their slopes you get minus 1. And in particular, okay, that if you have a general form of an equation of a line, okay, ax plus by is equal to c, that a line perpendicular to that, okay, is you flip the a and the b around, so you flip the coefficients and you change the sign of the coefficient on the y, okay, that an alternative line that is perpendicular to this line is bx minus ay is equal to f. And we had a nice little example here. All you do is you flip the coefficients of the x and the y, okay, and you change the sign of the coefficient of the y, and that gives you a line that's perpendicular to the line that was given. Okay guys, once again, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and I hope that this video, which was exploring the properties of the slope of the line, I hope that this was helpful, and I hope that it was I hope it was intuitive, and more importantly I hope that was helpful for you. So thanks for watching. Okay, bye bye.